Hi, my name is Erin Justice, and I'd like to spend a few moments with you today to tell you a little bit about a very exciting new product from Lincoln Electric, the VRTEX360. The VRTEX360 is a virtual reality arc welding trainer. This computer-based training system is an educational tool designed to allow students to practice their welding technique in a simulated environment. It promotes the efficient transfer of welding skills to the welding booth while reducing material waste associated with traditional welding training. The combination of realistic puddle simulation and arc welding sound tied to the welder's movement provides a realistic and exciting hands-on training experience. The VRTEX360 was developed in partnership with VRSim. VRSim specializes in the field of simulation and has produced many types of simulations, including flight and maintenance simulators. The Lincoln VRSim partnership is very unique in that it provides a combination of both virtual simulation and welding expertise. The VRTEX360 represents the next generation of virtual reality welding trainers and replaces the VRSim SimWelder in the marketplace. There are three primary components to the VRTEX360 system, one being the virtual reality welding machine, secondly, the virtual reality welding stand, and finally, the VR welding helmet. The VR welding machine is designed to look and feel like a real welding machine. The student sets the wire feed speed and the voltage or the amperage in case of the stick welding process in order to really enhance the training experience. The welding stand has been modeled after the Lincoln Electric Welding School booth. The stand can use 5 different welding coupons: the flat plate coupon, a T-joint, a groove joint, 2-inch extra strong pipe, and 6-inch Schedule 40 pipe. The system is designed to use these coupons in multiple welding positions. Plate can be welded in the flat, horizontal, vertical, or overhead positions. Pipe coupons can be welded in the 2G, 5G, or 6G position. The arm can be articulated to the left or right position, accommodating both left and right-handed welders. The virtual reality welding helmet looks just like a real welding helmet. Although there are special eyepieces on the inside of the helmet, each one aligns with the student's eyes. They can be specially adjusted to fit the student's face, and there are also earbuds on the inside so the student can learn what good welding technique sounds like. Each screen shows a slightly different image, so the virtual world is shown realistically in 3 dimensions. This allows the student to gauge depth. The welding machine can be plugged into 115 or 230 volt power. The student turns on the machine by pressing on the round green button on the front panel of the machine. In just a few moments, the system is ready to use. On the first screen, the student enters their name. All of the virtual welds made during this session will be tied back to this student name. On this screen, the student also enters the language in which they wish to use the software. The units are also specified, whether they be imperial or metric. In this screen, the student selects which welding coupon he wishes to weld on and also the position in which he wishes to weld. Once the coupon has been selected, the material thickness is then indicated. The next screen indicates which welding process they wish to use, whether it be stick welding, MIG welding, or the flux core arc welding process. Next, the student sets up the stand. The student selects the table height and also the arm height, then the arm rotation and the coupon rotation. In this situation, we are using a table height of 8, an arm height of 13, and an arm rotation in the C position. When the stand is set up, the student hits continue. The next selection that's made by the student is the environment in which they will be welding. This changes the virtual world that the student will be practicing their welding technique in. Since we're going to be using a welding process that requires a shielding gas, the gas mixture is selected, and then the gas flow rate is then indicated also by the student. The student then adjusts their weld machine settings. For the gas metal arc welding process, the wire feed speed and also voltage being used is selected. At the bottom of the interface of the machine, the polarity is also indicated. When the student has successfully set up the welding equipment, the Check Setting button is pressed in order to check these settings to determine if they are correct. It is very important when preparing to use the system that the student takes time to properly fit the helmet and eyepieces so they can see inside the environment. As the student steps back and looks at the stand in the virtual world, you can see that it looks exactly the same in the helmet as it does in real life. The student then positions his body to weld and, when ready, strikes an arc. The simulation reacts much like an auto-darkening helmet, where the surrounding area becomes dark and only the puddle, arc, and immediate area are lit. While the student is welding, the instructor can flip between 3 different screens: the student view, the instructor cam, and the graphing view. The student view shows what the student is seeing inside the helmet. The instructor cam allows the instructor to view the student's work from multiple angles and to zoom in and out. The graphing screen shows a graphical representation of the student's technique. When the student is finished welding, he or she can inspect the weld. The instructor cam provides an alternate method of inspection, and the graph gives detailed information about the welding technique used. The graph charts 5 different welding technique parameters: the position in the joint, the contact tip to work distance or arc length, work angle, and travel speed. Ideally, all lines will be grouped together along the red line, indicating that the student is using the welding technique that the instructor has requested. All technique parameter lines should be within the white tolerance lines. If a student uses technique that is outside the tolerance lines, they will peg up against the top or the bottom of the graph. Each line can be turned off and on independently so that each can be evaluated and discussed during the training process. The lower graph shows potential discontinuities that may have occurred over the course of the weld. For example, if a student pulls a long contact tip to work distance while welding with the gas metal arc welding process, they may lose their shielding gas and porosity can occur. As you can see on the graph, the long contact tip to work distance is noted on the top graph, and a line next to porosity can be seen in the lower graph. If we then do a visual inspection of that area of the weld, porosity is seen in that region. The right side of the graphing screen scores each weld technique parameter individually and then produces an overall score. Below the score is a pass-fail indicator. This system can be used to provide a correlation of the weld made to whether or not that weld would have passed under a specific code. Lincoln Electric has provided recommended welding technique parameters. However, it is possible for a welding instructor to manipulate the ideal welding technique and tolerances to accommodate for specialized welding techniques or to fine-tune the welding training experience. This can be especially helpful when the instructor wishes to loosen the tolerances to build confidence in a new welder, and then tighten them to challenge students as they become more skilled. Visual cues can be toggled on and off to be used together or one at a time. Visual cues turn green when the technique parameter being monitored is being done correctly. Visual cues can be used to aid a student that is having a difficult time with a specific portion of his welding technique, or they can all be turned on to allow a new welder to understand how it feels to use good welding technique using feedback similar to that of a video game. By using the keys that come with the VRTEX360, an instructor can change the welding parameter tolerances and access the weldometer. The weldometer is used to track usage of the machine. It records the number of virtual coupons that are used, pounds of consumables, amount of gas, even arc time that would have been used or occurred if the class were completing the welding tasks in a real welding booth. This information can help a school track the return on their investment in their virtual reality welding lab. If you'd like to learn more about the VRTEX360, contact your local Lincoln representative and visit us online at www.vrtex360.com.